Wabarakatuh, and a very good morning to all participants today. Okay, it's being recorded. Okay, thank you, Ms. Sabrina. All right, so good morning to all. Welcome to the first webinar, okay, under the Transportation SIG, Special Interest Group of HFEM, Human Factors and Economic Society Malaysia. So my name is Helmi bin Rashid. So currently I am the chair of the Transportation SIG HFEM. So today we are very lucky to have with us Captain Kanan Perumal, okay, among one of the experienced pilot we have here in Malaysia and also in under HFEM. Right. So today, first of all, I would like to thank everyone that is joining our webinar today. Right. Please forward the invitations to all of your contacts and also your colleagues. Okay. Because it is a free webinar, and I'm very sure that we will be having a very interesting topic today, right, on aviations of human factors. Okay, so I would like to thank also HFEM, Human Factors and Economic Society Malaysia, okay, for inviting us to hold a webinar today to share with all the participants. I would like to thank also Ms. Sabrina for arranging all the necessary arrangements for today's webinar. Right, so before we go further, right, before we go on board with Captain Kanan, right, before he starts to fly the airplane today. So I'd like to introduce Captain Kanan Perumal, okay, for all the participants, okay, of his background and also his past experience in the aviation industry. Right, so Captain Kanan Perumal, okay, currently is pilot, okay, experienced pilot with almost 25 years of approximately 16,000 flying hours. Okay, and he's currently captain on the Boeing 787, okay, and Dreamliner, right? And he's also experienced in being on board, okay, other types of what we call aircrafts, okay, like Boeing 747, Boeing 777, okay, even business jets, okay, and so on. Right, so Captain Kanan obtained his bachelor's degree in 1996 in aeronautical engineering from University Technology Malaysia, UTM. And he has a double degree, basically, right? Another bachelor's degree in aviation management from Massey University, New Zealand. And then he pursued his master's in mechanical engineering, also in aeronautical, majoring in flight dynamics and control, from University Technology Malaysia, UTM. And currently he's doing his double master, so double degree and double master in Master of Science in Human Factors and System Safety from Lund University, Sweden. So he was an adjunct professor at the Department of Aeronautical Engineering, Faculty of Mechanical Engineering, UTM. And then he currently moved as an adjunct professor at the Azman Hashim International Business School, AHIBS UTM. So there at AHIBS, he assisted in designing and establishing the first MBA, right? The first MBA to be introduced, okay, in Malaysia, okay, in aviation program. Right, he's also an adjunct at the Embry-Riddle Aeronautical University, USA, whereby he conducts courses on human factors and safety for the industry also. Right, so besides teaching, so Captain Kanan is also active in advising several programs at IHL, okay, Institute of Higher Learnings, and also assist most of these institutes in linkaging, okay, between academia and also industry. He was also the national chairman of the Malaysian Young Aviator School Program, Club Remaja Udara Malaysia, KRUM, right? So this school program is basically educating, okay, our school children, youngsters about the aviation industry, how to become a pilot, how to become okay, what do you call that? Aviation engineer. Okay, and also he was also the chief of editor for the Malaysian Human Factors and Economics Malaysia's journal HFEJ, right? And he is also members of the IEM Institute of Engineers Malaysia, okay, the Singapore Institute of Aerospace Engineers SIAE, okay, the Airline Pilot Association, and also a senior member of the American Institute of Aeronautics and Astronautics AIAA. Right, so from his background, okay, we could see that Captain Kanan Parumal here is a very experienced pilot in the aviation industry. So let's see today what he would like to share with us. Okay, something that I am very sure that we are very interested to know, okay, about things that flying above our heads, okay, what is going on, especially during the current COVID-19 pandemic. Okay, last year we have one of the talk by Captain ED, hosted by our member from the Transportation SIG, TS Joel, okay, about is it safe, okay, to fly during this COVID pandemic. So today we look into the aspect of aviation human factors, okay, and then we'll see how these aspect of human factors could improve our daily lives when we are flying on board. So we'll be having a Q&A approximately maybe at 11:15, okay. And so if you have any questions, okay, you could put it in the chat box, or you could ask it, okay, after the talk. Right, so I think Captain Kanan, he's already ready, okay, to steer the flight. So I would like to pass the platform to you, Captain Kanan. So we would like to invite Captain Kanan, okay, to further stop. Okay, you're most welcome.
All right. Okay, Doctor, thanks a lot for the introduction. So I'm Kanan, and there's in the video it's not so good lah. Maybe because of my camera, there's a lot of white spot and all that. Just regard that. Okay. All right. So this is invitation from the HFEM. In fact, I'm part of them. So welcome for this webinar. Hopefully, this is a bit of useful for you all. And that's me when I'm working. This picture was taken maybe about 4 or 5 years ago when I was a bit fat. Now I've lost some weight. This is on a 777 aircraft. Sorry, 777 aircraft. And what I try to show from this picture is that we are actually cruising at about, I think, 39,000 feet and flying almost like Mach number 885, or that's about 900 to 1,000 kilometer per hour. Aircraft is so stable, and if you look at the cockpit, it's very advanced cockpit. It's a 777 aircraft, 777-300, I think. And we don't hold anything there. We're just taking a picture. If you look at the cockpit, you see so much of instruments, and this is our work. We involved with a lot of automation, and there's a lot of human factors issues involved in this. And the pictures on the right, you see the on the top right, you see like a small screen there on the top. That's called head-up display. It's all these advanced aircrafts now. We have that for us to interface with the instruments easier way. And then also, we fly day and night, and a lot of nice sceneries, but also human factors involved there, because when you sleep, you wake up, and then time changes and all that. So a lot of human factors issue are involved in our work day to day. This is only the operation side. Later we'll talk about engineering and air traffic control. Okay, as Dr. Helmi introduced, in fact, this talk came about because we had a meeting under the special interest group transportation. So I was was selected as the aviation guy, aviation section. Me, myself, and Mr. Joel. He's an aircraft engineer. So then we came up with this talk eventually. So what I'm trying to present through this webinar is basically just introduce to the aviation industry some basic concept of human factors that we use, and then some limitation and performance that's relevant. to our day-to-day operations in the aviation industry, and also a little bit on practice model error and some aviation accident. I got a video, a short video, and finally look at some of the challenges and opportunities in the industry. Right, this is the way I organize the talk. A little bit of history, what's the aviation system. Just introduce the aviation system in Malaysia, or what are the rules and regulations, and then I will look at the human factors itself, the human model and error, and then finally I will end this with some trends in the human factors and challenges and what are the opportunities available, and finally with some Q&A if you guys have it, you know. First of all, we always have this confusion, you know, what is aerospace and what is aeronautical, and these two terms are used interchangeably. So this involves initially it was aerospace aeronautics, but now more universities like to use the word aerospace. One of the reason is that it sounds more glamorous, and of course technically you if you want to look at it, you know, anything up to about 10 kilometers, if you look at the chart on the right, you know, that's where the air is a bit denser, and then we can fly aircrafts, normal aircrafts, you know, because we use the normal engines, jet engines, which need air. But if you start going above that, you know, the air becomes less dense, less rare. You cannot use the same propulsion system. Then it becomes aerospace because you are going into venturing into space, you know, like rockets, satellites, and all that. You need a different type of combustion system, thrust system to bring the aircraft up. So that's the main difference, you know. Other than that, if you look at the temperature changes and the density and all that, right? A bit on the history of aviation, you know, when people wanted to fly, obviously they look at birds and then they're trying to follow, you know. So like this guy, you know, these are all Greek and Romans. They're trying to fly, but most of them eventually end up dying, crash, and then dead, you know. So they come up with gliders and all sort of things. And one day, after a lot of trials, these two gentlemen, the Wright brothers, who actually, you know, have a bicycle shop, you know, they came out with a design and they tried out this model, and finally they managed to fly. Okay, so this one here, because they managed to fix a motor behind it, you know, with the propeller. So finally in December 1903, they launched the first flight, powered flight. It's called the powered flight. Before that, they were flying machines, but it's all like gliders and that sort. But this one was the first powered flight. So from there on, you know, aviation took off. You know, they came out with balloons, can fly faster than speed of sound. Then women start to get involved, and then you have this famous Concorde, which can fly between New York and London, you know, within 3 hours or so. So the aviation becomes progress very fast. And also they started to design, you know, autopilots. This guy is trying to demonstrate that, you know, the aircraft is flying on its own. He climb out, trying to demonstrate the new system. Then from there on, you know, aviation has took off even faster. You know, like this Virgin Atlantic Galactic, which they, you can go to space, and you have solar impulse, which can fly non-stop, high altitude, and Islander, another new concept. And then this guy here, interesting, Jetman. You know, he just fixed a wing, and then he got this small jet engine fixed, and then he flies. Right, for example, this is the one on the top right. You know, he flies in Dubai with a 380. We have very advanced drones now, fighter jets, and also spacecrafts. So eventually, the aviation, as for example, in the cockpit itself, the design of the cockpit, from 4-5 people in the cockpit, it starts to reduce, and then all this bottom one is all the advanced aircraft, you know, 777, 787, 380, and then 350. So the aviation is you know, advanced a lot. And if you want to classify, which a lot of people get confused, you know, when they say aircraft, some use aeroplane, you know, the Americans like to use aeroplane, then we use aircraft. So there's lighter than aircraft, heavier than aircraft. So the one normally we call aircraft is mainly heavier than aircraft. The lighter than aircraft, you can even categorize that into balloons, gliders, all the seaplanes and all that. So it's a good chart to get an idea. Some of the earlier mistakes, the human factors, how we started was basically from psychology. A lot of this research being done during the World War, because they realized that World War II mainly, because they realized that they have the best trained pilots, but accidents still happening. So they started to study why these things happen. One of the earliest study was done by this guy called two gentlemen, Fitz and Jones, in 1947. How to configure the knobs, the flaps and the gear in the aircraft cockpit. So that's when the new term, human factors and ergonomics starts coming. Another example will be this helicopter. We in Malaysia we call it Nuri. It's a Kosti aircraft. Also crashed, and because the way the controls were designed, or the warning system were designed, the pilots could not see it. The location of the warning system. When it shows red, but they don't realize that there's some warning coming, so they continue and then they crash. This is what I said about flap and gear design, because they were, instead of putting the flap is what you see in the aircraft. When you're sitting in the aircraft near the wing, you can see this thing coming out when you're coming into land. So that's called flap. And then the gear is our normal landing gear. So just to avoid that people making mistake, so they start to design the flap, the lever, and then they put this thing similar to flap. So when you touch it, you know that you are touching a flap, the shape of a flap. And then in the gear, at the end of the handle, they put like a gear, so that when you touch it, you know that it's a landing gear. So you don't mix it up. All right. Another design like the Air Force design, F-16 fighter jets. If you look at the seat, it's reclined a little bit, say about 20-30 degrees, like this one here. And the pilots who sit in this, fighter pilots who sit in this, they sit at a certain angle. And there's two reasons. One is they design such because the canopy is not very high, all right, to reduce the drag. And another reason is that because when they do a lot of high gravity maneuver, high G maneuvers, when you have a reclined seat, the pilots can take more G pull. Okay. Another one is this Apache aircraft. We don't have it in Malaysia. It's America and some other advanced countries. Very advanced aircraft. And the pilots use like what I said is head-up display. They have this helmet mounted head-up display. So, and from that is focused in only one of the eye, and they get a lot of information through that small piece of equipment there. So what happens is that because one of the eye is always focusing on that, so this generally this Apache pilot's eyes, one of the eye becomes smaller than the other one because one of it is always focusing on that. Okay. Of course, the seat design, cockpit seat design is similar to car, but because seat must be very comfortable for the pilots, so there's a lot of technology into the seat design. This is just a joke, if you all know about these kamikaze pilots during the World War, these pilots basically go there to die, But funny part is that, even though they know they go there to die, if you look on the right seat, right picture, they only helmet. So you don't know why they do that, but just to feel safer, I guess. So now the second part, I'm going to talk about the aviation system itself in Malaysia. So if you look at it, basically it consists of three main elements. One is the transportation system, the airlines and the industry itself. And then you have customer. You don't have customer, you don't need the industry. And then, of course, all these are regulated by the regulatory body. And in Malaysia, it's called Civil Aviation Authority of Malaysia, CAA. And then the aviation can be divided into two. One is civil, one is military. Today, we just talk about civil aviation. We have commercial aviation, and then we also have general aviation. General aviation is all these flying school, all these small aircrafts, business jets, and all that. Okay. And in Malaysia, they came out with this blueprint, aviation blueprint, with 7 strategies, to increase the aviation industry in Malaysia, to attract, prepare, and all that. But there's something that is, I realized that is missing in this all these blueprints. We will talk about it in a while. So this is all the blueprint, how to increase the jobs, increase the revenue, and then they divided into different parts. All the aviation industry, which is in Malaysia, all the first tier, the supply people, all the big companies, Spirit Aviation, Honeywell, Safran, and then you go down all the way to Tier 4, which supplies small components in aviation industry manufacturing. Right. We also have operators, a few operators in Malaysia. Like the normal one is Malaysia Airlines, AirAsia, Firefly, Maswing, Malindo, then small, including the Air Force, Post. The new company will be STS Aviation, supposed to start, but I think because of COVID, they delayed. And many places in Malaysia, we have aircraft, aviation-related industries, manufacturing, flying schools, and all that. And obviously, universities are involved, all the academic institutions, training and education. But again, as I said just now, there's something is missing. One of the things is that they only talk about the technical stuff. The human factor side, the economic side, there's actually, I find that nobody is looking into that. So there's a gap there, and hopefully that our group here can do some work for them. So in fact, this is one of the reasons that we are having this talk, to open up this idea that there are opportunities inside this industry. Okay, this industry generally, in fact, is very, very highly regulated industry. Everything you want to do is you need to get an approval, and it is control. We can say like a control by the main people, which is called the International Civil Aviation Organization, and which is regulated, the biggest regulator. And then it's supported by IATA. IATA is International Airline Transport Association. This is mainly for the airline, passenger services and all that. So if you look at in Malaysia, ICAO basically in Malaysia itself, in a smaller scale, is the Civil Aviation Authority, CAM. And then IATA, which takes care of the passengers, you lose baggage and flights delayed and all that. If you want to complain, you go to the Malaysian Aviation Mission. The bigger authorities, national authorities, are the Federal Aviation Administration in America, and then another one is the European one, EASA. So in Malaysia, it's called CAM. So under the ICAO, they have a lot of annexes, which basically these are the documents that is referred to, so all the annexes, so if you want to know something, you go into one of these documents, the details are inside there. So for us, I think generally is the Annex 19, safety management, and also the human factors comes into that also. It's called a safety management system. So you get a hold of that Annex 19. So then again, what is human factors? So ICAO has defined human factors as it's about people, working with environment, and then the relationship between equipment and environment. And it involves human. So that's where the human comes in. Right? And twin objective is safety and efficiency. That's end of the day, we do all this mainly because of safety. So in summary, we can say is basically to reduce human error, increase productivity, enhance safety and comfort, with specific focus on interaction between human and other things of interest. And ICAO, they have their own manuals, as I said, all these assembly, the meetings, and then they come out with these different manuals. For example, they have human factors guideline for aircraft maintenance, management, organizations, and all that. So another one is also all the other documents, human factors related documents. So if you want to go about aviation, we can find all these, about 16 documents. Probably now there's a bit more. Talks about air traffic control, maintenance, cabin safety, even culture, automation, crew resource management, and all the different documents. Right. Some more manuals, documents, human factors training manual, and all that. So those interested, you can just go and find these documents to do more knowledge on this. In Europe, they have this also another document, so called the CAP 709, Fundamentals of Human Factors Concepts. And as I said, IATA, they also becoming like ICAO and try to do some business and all that. They also run human factors courses. Okay, In fact, now online you can do all these businesses in this process. So when you talk about human factors, sometimes we mix it up with ergonomics. These two is always closely related. The topics that we always look at is about information processing, sleep, trial and error, decision making, and all that. So one is static measurement, and also we also look at when we are dynamics. Again, concepts, communication, stress, overload. This similar to other industries, but in aviation, we look at it into in a bit more detail. And under the ICAO, or in fact under the CAM, we have a lot of other regulations or acts, the Civil Aviation Act, aircraft offences and all that. Although all these are not directly involved with the human factors, this just for your knowledge. Right? As I said, it's a highly regulated industry. Okay, and one of the requirement is for the pilots, for example, for the pilots, it's a requirement for us to pass human factors courses. Okay, we must pass part of our license. Similar to the maintenance engineers, aircraft maintenance engineers, we call it licensed aircraft maintenance engineers. They also need to take many subjects to pass it. And that module, I think module 7 is one of the human factors modules, similar to the air traffic controllers. Also, they must pass this human factors module. All right. So as I said, there's mainly three segments in aviation. If you look at it, there are many more, but I will just talk about the three. One is the flight operations, pilots, cabin crews, and then how they interact in the cockpit, how they work with the modern cockpit, a lot of technology. And then in fact also the cabin crew, when they are dealing with the passengers, there's a lot of human factors involved even behind. Okay, this is another thing. When the aircraft is parked, you see next, when you're at the airport, you can look through the window. When the aircraft is parked, there's many equipments that's around the aircraft. So there's a lot of human factors involved. There's a lot of accidents that happen. This tow truck went and hit the aircraft. When they're doing the supplying the catering, some accidents happen. When refueling the aircraft, sometimes there's a fuel spill. How the safety procedures that we need to follow. So there's a lot of things that happening around the aircraft. How they load the cargo. When sometimes when they trying to fix the aero bridge, aero bridge to the aircraft doors. There's also some accidents that happen. Sometimes the aircraft, when it's coming into park, they also hit the aero bridge. So there's a lot of human error mistakes that happen, and all these are human related errors mainly. Okay. Next one is aircraft maintenance. If you get an opportunity, maybe the human factors group, we can organize a trip to the aircraft hangars, the Malaysian airline hangars. Either we can go to Subang or KLIA, see how these aircrafts are maintained. These things, the hangars works for 24 hours. Different light condition, time, night time. There's a lot of accidents happen. Generally, this accident happens early morning because of not enough sleep. People die in the hangar. Because they have been crushed by the flaps. When they're doing some tests, something falls down. The aircraft wing here. They're doing the inspection of the wing. Also, some errors happen. Marshalling the aircraft. So aircraft maintenance also involves a lot of human factors issues. All right, as I said just now. And then the next segment will be the air traffic control. This is another area that many people doesn't know, which is very important in the aviation industry. These are the people who control the aircraft. They sit in the control tower. That's what most of us think. They also sit in the air traffic control rooms. Okay, like in the KLIA, we can also again organize a trip. Of course, now we can't do it because of COVID. But this is how the working environment. Very very busy. Very very busy. They're controlling a lot of aircrafts. Okay, and this is the air traffic system. We have sort of highway in the sky. Over Malaysia also we have a lot of highways on the sky, and these are the air traffic controllers. We need to control this aircraft's movement on the sky, right? This what that from the movies we think that this is how they have the display, but now the displays, the screens that the air traffic controller use have changed, very advanced screens, so they need to work looking at the screens and talking to the pilots. All right. This is how a typical control center looks like. We can also organize a trip, our control center, which is located in Subang. They control all the aircraft flying over the Peninsula Malaysia. They have another center in Kota Kinabalu and another one in Kuching. Okay, all right. So very interesting. A lot of ADC related errors. Okay, procedure non-compliance. So there's all these are human factors related errors. Okay, on a typical day, this is the screenshot. It's an old screenshot before COVID. So if you see the number of aircraft flying daily, in fact, you can log on to this website called Flight Radar 24, and you can see the number of aircraft which is flying. Imagine that each of these aircraft carrying about 100, 200, 300 passengers, and if there's any error accident because of human factors, there can be a lot of deaths. So that's why this human factors is a very important area that we need to concentrate. And one professor, Professor Perro, he come up with this theory called normal accident theory, and then he linked with how the systems are coupled, whether it's lightly coupled or it's tightly coupled, and then the complexity of the system. So if you look at the top right quadrant, aircraft, which means actually it's aviation industry, is very tightly coupled industry and very complex industry. So there's a high chance of accidents to happen. So space, we had two big accidents because of technical, mainly because technical, the Challenger and another spacecraft which is crashed on the coming in. There are also some other major accidents that happened. I showed the disaster, Columbia and Challenger disaster. Tenerife, the number two, we'll watch a video later on, two aircraft 747 which crashed. This is a big crash, 500 over people died in this crash a few years ago. And then we have, also all rate, and all this also similar to the aviation industry, and it's all because of the human error. On a typical day, this graph shows that on a typical flight path of an aircraft, from takeoff to landing. But we look at why these accidents happens, or what portion that these accidents happen is mainly, if you look at here, is 13% on the takeoff and about 48% on the final approach and landing. Okay, so once you have airborne, it's basically quite safe. But on the takeoff and landing, these are the two portions that is very dangerous section. And mainly because human factors again, because coming into land, the pilots are tired, the weather can be bad, we don't have enough altitude to recover, so that's the main reason, because these accidents mainly happening during the landing. Okay, so if you again human factors, so you look at how the pilot's mental state, or workload. So during landing, if you see here, your capability and then the demand is very high, so the tolerance is very low, so there's a high chance of accidents happening during that period. Okay. But even having said that, because of technology, the accident rates, the crashes has actually dropped a lot, over the years, but it will never become zero, because that's where the human element is always there. So human makes error, and accidents still happen. If you look at the statistics, flight crew, aircraft, weather, maintenance, so flight crew make the most of the errors. As I said just now, from technical has reduced tremendously, but again, the human cost is always there. And when an accident happens, it has two effects mainly. One is obviously we lose, the airline lose a lot of business, because people are scared now to take that airline, and also it damages the reputation. So another day, the main word, the key word in aviation is safety. So all these human factors and efficiency and all that, we do it because of to improve their safety. And human error is the main cause, we can say main reason, all these accidents happen, when you look at human factors. So this guy, he came out with this, it's called a dirty dozen, 12 reasons that we make mistakes, distraction, lack of resources, stress, lack of teamwork, fatigue, lack of knowledge. All these are involved in human factors. We can talk about this separately in some other section. Okay. So of course, to err is human. Human makes always make mistakes, and we need to understand why human make a mistake, and that becomes a science and part of the factors process. Some of the models that's always been used when you talk about aviation, I'm not sure about other industry, but this is one of the models that is quite famous. It's called the shell model. How human, which is in the middle, interact with hardware, software, procedures, environment and all that. So eventually they found out that we also need to look at how human and another human interact. So that's where the shell model comes in, liveware and liveware. All right. So, okay, this one of the accident I told just now. So we will watch a short video, about 3 minutes video of these accidents. That's where the human factors become more important. Okay.
Sunjet 282, proceed directly to runway, backtrack and hold.
Los Rodeos Airport on the Spanish island of Tenerife is busier than it's ever been.
BA 783, hold short of the runway and stand by for taxi clearance.
With so many planes parked in the taxiways, the controllers instruct departing flights to taxi along the airport's only runway to get into position for takeoff. One of the planes waiting to get to Las Palmas is Pan Am Flight 1736. The Pan Am crew is ready to get back in the air, but they can't taxi to the runway. A KLM 747 has stopped in front of them to refuel.
Tenerife KLM 4805, you finished refueling, requesting clearance for startup.
He said, follow KLM down a runway, backtrack, make an exit to get around back of KLM. So that's what we were doing.
First Officer Bragg is unfamiliar with the airport. He checks a runway diagram to help find their turn.
Okay, that's this one right here.
Goes ahead. It's going to put us on the taxiway.
As they taxi, they listen to the tower controller tell the KLM crew ahead of them what to do after departure.
You are clear to the Papa Beacon. Climb to and maintain flight level 90. Right turn after takeoff.
Roger, clear to the Papa Beacon. Flight level 90, right turn out. We are now at takeoff.
Okay, stand by for takeoff. I will call you.
And we're still taxiing down
On the runway, Clipper 1736.
Papa Alpha 1736, report runway clear.
Okay, we'll report when we're clear.
Thank you.
The Pan Am crew will be turning off the runway in just a few more yards. But now something's wrong. First Officer Bragg can see a plane through the fog.
I think he's moving.
Look at him. That idiot's coming.
Saw KLM too.
Get off. Get off!
Captain Grubbs tries to steer clear of the oncoming KLM. But it's bearing down on them at nearly 200 miles an hour.
He had lifted off the runway. I could see his rotating beacon underneath.
Get off, get off, get off! Get off, get off, get off!
And then I ducked and said a real quick prayer, trying to hope he misses us.
Okay. So this
Sunjet.
this accident happened in an island called Tenerife, where 2747, Pan Am, which is an American airline, and a KLM from Holland, supposed to go another island, because the other island, the airport had some issues. There were some bomb, So they diverted to this small another airport, and there's too many aircrafts adapted there. And now we have an American, now we have a Dutch, and then the local people, I think the Portuguese, they speak Portuguese. So there was issues of communication. There's only one runway, the weather was coming in. They couldn't see each other, and then they crashed. This is one of the biggest crash in the aviation history. 500 over people died. So errors can happen. This is, looks very simple, but a small mistake, because they didn't hear what is the instruction, and a lot of people died because of that. The locally, Malaysia, there was one case long ago. The aircraft got hijacked and then crashed, 737 in Tanjung Kupang. It's basically hijacked. Yeah. Another one is Flying Tigers. This is a 747 cargo aircraft which crashed near Subang because of also again miscommunication. They were cleared to 2,500 feet. The TO2, they heard it as TWOs. The way you hear the things was wrongly heard. So instead of going to 2,400 feet, they went to 400 feet. So the 400 feet, the hill was there. So they hit the hill, and then this aircraft crashed on the hill. This happened in Malaysia. So this how in aviation we pronounce words. So that's very important. A, alpha, bravo, so that we don't confuse. And also numbers 1, 2, 3, 4. There's a way of pronouncing in aviation. Another crash happened in Kudat. This is a smaller aircraft, Mars Wings aircraft. Again, the pilot was stressed. They couldn't land. They tried to go around, and then they hit the fence, and then this aircraft crashed. This was quite a recent one. Happened in Subang. Business jet landed at night in Subang, and then at that point of time, they were doing some work on the runway. Some miscommunication between air traffic control and the engineers doing the work there. The aircraft landed. He wants to exit the runway. The wing, there was a car, a van waiting on the side, and then the aircraft wing hit the car, and then the person sitting inside here passed away. I think you got cut off. So simple, looks simple, but accidents happen because of miscommunication between between the humans. So one of the law, we always heard about this Murphy's law. If something is going to go wrong, it usually goes wrong at the worst time. So, right. So even looking at the accident investigation, they also again ICAO manuals, which is talking about factors. So why we look at all these accidents happen? Because we over time we drift. When we think that it's okay. So instead of getting the expected performance, we drift to the actual performance which is expected. So this is part of the human behavior, right? So this another professor, Sidney Decker, he came up with something. When you look at Murphy's law, he said Murphy's law says that when something goes wrong, it will definitely go wrong. But why it goes wrong? Because we accept the error that we're making. Over time, we start to accept the error, and then because of that, accidents happen. This another concept that is deviation, normalization of deviation. Okay, this is what we want, but we deviate to a norm, and that will become the new norm. So that's actually is a error that we are making, and then eventually an accident can happen. And when you look at the accidents, the errors, it's all lined up. It's all lined up like the domino. If something happens, another thing will happen, another thing will happen. So accidents, unsafe act, social environment, all that. Finally, we have an injury. Okay. So what we can do is remove the error. If we can remove one of these error using our whatever technique of human factors, we can avoid this error. Another method or model that is always used in aviation is this thing called Swiss cheese error. It passes through each element, and finally accident can happen. All right. So we can combine these two with the shared model. So end of the day, we try to break these errors, the chain of errors, using our knowledge on human factors. All right. Take a pick. Blame error or try to learn from the failure. We cannot always just blame that error and error. Okay? We need to admit it We must be aware that we can make an error, and we must be able to admit it. The moment we start to hide our error, that's where more dangerous. Okay, it's another mistake people make until cargo aircraft, they didn't put a tail stand at the end here, and then when they start to load, it can go like this. Many times this kind of happens. Okay, so how we want to do it is we need to think about it differently. We look at the issues differently. Right? Okay, instead of we saying that human error is the cause of trouble, we want to look at that as a symptom. When people are making error, we want to look at the symptom. That shows that there's some problem inside there. So we need to go and look at the system. How things are designed and how people work in that places. Okay. So the new is people matter more than anything else. Okay. Of course, we always get punished. So we're trying to avoid that. We need to accept that error is normal, and we work on that. Okay. Another person come up with this concept of safety 1 and safety 2, which we want to learn from the errors. We look at the issues that are happening under 80. Not like what we are looking at. Somebody make mistake, we try to find who made the mistake, and then we try to punish him. Instead of that, we want to find what was the reason he made a mistake. Right. So this concept called safety 1 and safety 2. Right. And of course, related to that is called resilience. We want to bounce back. We made a mistake. We try to improve the mistake. Why human make this error? What are the factors involved? And then we come back. So, and again, it comes with this concept of resilience engineering and high reliability organization. Aviation, one of the high reliability organization. All right. So these two are involved. So understanding human factors will help you to set organizations up to succeed. That's what we wanted to eventually come up with human factors, and then ensure that we are safe. So some of the challenges, the latest challenges is obviously automation. As technology gets better and better, we're coming up with AI, a lot of drones. Now people talk a lot about drones, and nobody actually looking at the human factors of drone operations. So that's one area that we can go into. Then joint cognitive system where human and machine interacting. So now people are outside the aircraft. So drone is there. How do we work with them? And then now we have swarm drones, group of drones working together. So these are all the new challenges which are coming in. Human factors issues contribute to more aircraft accidents and incidents, as we know. Because it gets together. Small mistakes can get together. Human error includes flight crew, maintenance personnel, air traffic controllers, and others who have direct impact on flight safety. So what we want to find out what's actually is behind this human error. So human factors can help that. Again, another person, is Sidney Decker. He has many books on talking about. We cannot just go and blame it's because of human error, and we need to find out why is it. Okay. Right. And when we start looking at it, why is it? Then we can look at environment, air traffic maintenance, display, how these systems work together. All right. So how can human factors assist? So first, we need to accept it. It can happen to anyone, so we need knowledge. So that's where these human factors studies comes in. We can improve on the design, on the procedures, and how we manage it. Okay, and then as I said, it's a emergent, so it's a combination of many things. When we look again at the domino effect or the Swiss cheese effect, it's actually because of a combination of many effects, multiple factors. So eventually, we need to find a balance, whether we want more efficiency, more productivity, optimization, or safety. How much is safety, and the human factors can play a very important part in this. And we want to use the resources properly. As I said, safe optimization, and I've been saying from the start. In fact, that is the main reason. One of the reasons that I want to give this talk is this is one area. Human factors is really under researched area in aviation in Malaysia. That's my take on that. And so there's a lot of opportunity, and our group can contribute a lot in this. Okay. Of course, we have our own journal, and in fact, we don't have any papers inside this which is related to aviation at all. So we can start to write papers related to aviation. All right. So hopefully, our group, human factors group, we can become the humans behind the human factors. So to improve the safety of our aviation industry and be the forefront of human factors research, development, and practical application. So hopefully we get more people interested in the aviation research, and I can help out. In fact, our SIG group can help out to link you all with the aviation industry, and from there, we can do a lot of research. There's a lot of opportunities. People ask me, but in fact, now since I joined, I know people, and if you guys also interested, please let me know. We can go to air traffic control or engineering or operations, at Asia, and we can work, because each of them, they have their own human factors group also, but they don't really have actual researchers, because they're operational people. So all these people, you guys from the universities and from the industry, can actually help to do research on this stuff. Okay, so thanks a lot for this time. I've taken probably about less than an hour, 40 minutes or so. And thank you very much. And any question, Doctor, help me. You can open up for questions. Thank you. Yeah, Doctor, I can't hear you. Hello. I can't hear you, Doctor.
The floor for any participants that would like to ask for any questions regarding this topic. Right. Okay, in the chat room, we do have from Nick Muhammad Fajrul. Hi, Captain. Can you share the slide with us? Right. So maybe
these slides, okay.
In spreading the slides, Captain.
Okay, I will see which one I can share later on. I will share with you.
Ting Su. Okay, Captain Pomal, does the airline industry screen for pilot mental fatigue before allowing a pilot to fly? Okay, Captain.
Okay, in fact, it is not directly done.
You are
because
muted.
we are all...
Okay, okay.
Okay, hold on. Can you hear me?
Yeah, yes, sure.
Yeah, okay. Mental health, it's actually, this is all checked during our interview process. During the interview, you can see what kind of person. Of course, over time, we have annual medical checkup that we need to go. So in fact, the doctors check on us also, even though they don't check actual mental, but they can see us, whether we are a normal person or not. Okay, of course, when we go to work, we have a lot of our colleagues. If you find that something is not right with the other person, we need to highlight this. So there's no mental check at every flight, but our colleagues help us to check on us. If you find that somebody's not right, you better tell the authority something's not right about it.
Okay, right.
This is something that is very difficult to control.
So it means that there's no, we could say SOP, is it, for every flight?
There's no actual SOP written.
Right.
But we check on each other. You can see people whether there's something wrong with him, mentally. When we talk to him, we will know. So that's why you need to have pilots with very stable mental condition.
Okay, so we do have Mr. Remy from NIOSH. Okay, good presentation, Captain. How the fatigue management system was implemented in the airlines industry?
There's always a gap there. They're trying to come up with this fatigue studies. There's a FRMS, fatigue flight crew rest management. there's a new manual, new research coming up. For example, this is mainly being done for all these long range pilots. They do fly non-stop 19 hours, 18 hours. Then we have short rest period, and then daytime time zone changes and all that. There's a lot of opportunities to do a research on this. Airline by itself, they are doing their own research, but of course they trying to, we have limitations on how many flights we can do, how many hours we can work per year. We are limited for pilots. In fact, we are limited to can fly for 1,000 hours per year. All right. And then Of course, the company trying to keep it to 1,000 hours. We cannot bust that. Become illegal. The airline itself, the company itself, they want to press workers a lot. But of course, there's a union try to come up with a balance. How much can you work? So there's a lot of research on this. So anybody interested, you can always do research on this. Yeah.
Okay, hope that answers Mr. Remy's question. Okay, from Tingsu again, is there currently any research going on to detect pilot fatigue objectively so far? For example, using EEG.
There is always research, within the airline. Within the airline, they are doing research. But again, there's a published requirement by the ICAO, as I said, and of course, airline will have their own requirements. But this is very subjective type of research, fatigue. So again, as I answered Mr. Remy just now, there's still a lot of opportunities. They are doing it, but not that advanced level, I could say. It's just that pilot report. Okay, the pilot, they feel tired, then they come and report that I'm fatigued. But there's no actually scientific type of research which is done. In fact, I think in Malaysia. So you can go into that. Okay, even for engineers, even for air traffic controllers also, because they work long hours, right? So even that section also, people ask me if somebody can do research, because they work on shift, air traffic controllers, they work through the night. So how many hours they look at the screen? So there's a lot of research can be done there.
And they are always sitting, right?
Yeah, they're always sitting, looking at the screen. The seat, when the new control center, there's a new control center going to come up. I think already constructed. They're going to start operation sometime this year, which is near KLIA. Even there are companies selling these seats. The chairs, ergonomics type of seats. So this type of research, there's always huge. You can go and do it. Yeah, yeah.
Okay, we do have from Amar Sam. Good morning, Captain Kanan. Amar Sam from Pipit Consultant.
Yeah.
Do you think that local aviation staff culture from respective country contribute to making error or neglect in complying routine? Routine check or practice?
Okay, culture. You talk about culture. Yeah. Culture is again another big issue. Aviation culture, not necessarily aviation culture, but other industry also. But in aviation, it becomes very important because aviation is a international business. Instead of working within Malaysia. For example, like me today, I'm probably in Malaysia, then I'm flying to, let's say, New Zealand, right? So now I'm working with a different type of people, different type of group. In fact, my crew can be all also from different countries. We have Japanese, we have Chinese, we have Korean from India. So a lot of cultural issues are involved. That's why we come up with SOPs. Everybody follow the same SOP. So it's a again big issue, big area of research. So culture is if you look at HOSFET, if you can Google HOSFET, he come up with all these 4 dimension of culture. So your question is contributing to making, yes, the answer is yes. It is. Even within organization, you have cultures. Engineers have their own culture, pilots have their own culture. How you work with them? So it is yes. It contributes.
Okay, let's go to Mr. Kavi's question from our transportation SIG. What is the resting period for pilots from one flight to another?
Oh, this is a complex issue. This is very complex issue because there is a requirement, because where do you fly? How many hours time zone do you go? How many days of or hours of rest you had before that flight? And how long is the flight? Sometimes we have 4 pilots, sometimes we have 2 pilots, sometimes through the night. So it is the period varies. So there is a regulation by the ICAO, and then the airline will also have another regulation by themselves. But of course they cannot go. ICAO regulation limits them. So this again another complex issue. It's really complex issue. How many hours exactly I cannot say. You need to look at the.
But Captain, for local flights, like local flights, like we go to Asia, right? So we do see the aircraft comes and then check in and then go again. So means that how many flights does they go normally for local flights?
It doesn't go on the flight. It doesn't go on the flight. It goes on number of hours. Generally we need about 10 to 12 hours rest. But I do not know what's the requirement for Air Asia. So let's say I work today. I can do many flights. Today I can go KL, JB, Penang, Langkawi, Kuantan, Kuching, KL. Right? So I do the sectors, many sectors. Then for me to on the next flight, I need at least about 10 to 12 hours rest. And then in a week, how many hours can I do? So you total up all this number of hours. In 28 days, we can only do 100 hours. In 1 year, I can only do 1,000 hours. So if I'm coming to this limit, the company cannot roster me for a flight. I cannot work. It become illegal.
So that's the standard, is it?
So yeah, there is a standard. Yeah.
Okay, we do have another question from Mr. Rini again. How do aircraft crews deals with different time zones? Normally, how many rest days given after prolonged flight, or cross time zones flight? The crews.
Okay. Again, there's no there's no one answer for it. Again, we must look at the rules in the company, and then also the ICAO rules, right? And it varies from airline to airline. For example, last time in my company, every time I come back from a European flight, we will get 3 days off. Now it's reduced to 2 days. Okay. Either I'm going to westwards, I'm going to Europe, and then come back, and then after that I go to New Zealand. So either I'm going to east or I'm going to west. So here going to New Zealand, I have 5 hours different. I go to Europe, I got 8 hours different. So in a week, I can have 13 hours different. So my sleep pattern, become zombie. Become zombie. So we that's why you see we actually need to rest a lot. And of course, on board we have also rest periods. Because sometimes, let's say we are doing a non-stop flight to America, we can see sunrise, sunset again. So we can see many times. In fact, we are flying over the, close to North Pole. Sometimes we don't see sunset at all because we are following the sun, So we are really affected. So we have a sleep pattern. You sleep short, then you go to work, and then you come back, you sleep longer. So go to America. We are now 12 hours, 13 hours different. So Malaysia is to be sleeping, but there is daytime, and then in 2 days there, we need to come back again. So the answer again, how do aircraft crew deals with? So we need to have our own coping method. You're tired, you go and sleep. Don't fight the sleep. Don't fight. If you fight, then you go into zombie and then you start to making mistakes. Right? Yeah.
Okay, Captain. Okay, we do have a question from Norizan Hashim. Hi, Captain. Could you please share the 56% aviation accident caused by the flight crew in terms of what errors? What are the errors?
Many types of errors.
56%.
Okay, many types of errors. It can be procedural error. It can be knowledge. You don't have enough knowledge. He can, maybe because of fatigue, he can start to make error. So it's many types of error. Technical, it can be also technical. So there are many types of error. You can Google this and look at it. So procedural, knowledge, fatigue. What I said just now. Yeah.
Okay, Captain, just to ask regarding this question, between human errors and also the aircraft malfunction itself, which one is the biggest one?
As I showed one of the chart, the technical error has reduced a lot. The technology has improved so much. Okay, you see the engine is turning at 50,000-60,000 RPM for many hours, for 18 hours, but nothing happens, right? So the technology has gone very high tech. We fly, we don't touch the control, we only touch it for 5 minutes, take off. Then after that, we put it on autopilot. Then we don't touch it until we land almost, In fact, we can do an automatic landing. So the technology is very high, but human is inside there. Of course, then we start to talk about, we want to remove the human from the system. That's where we want to talk about pilotless aircraft, right? But the question is, who will fly in an aircraft? There is no pilot. Then there comes trust issue, because the technology has certain limitations. It cannot make decisions. We talk about AI and all that, but of course there's certain decision making. The machines are still not capable of making it. So you still, at least for the next many years, human has to be there. Yeah.
Okay.
So technology is improved. Yeah.
All right. We have a question from Nick Moore Fajarul. Can Captain explain what is artificial feel in flight controls?
Okay, artificial feel, yeah. Before this, the aircraft, you look at the small aircraft, the one in the training school and all that, it's all connected by cables. When you pull, you can feel it, it's harder to pull because it's connected to the control surface. But over time, it's gone to a technology called fly-by-wire. It's just artificially introduced feeling. So you actually, what you feel in the control is not actually what is the amount of force actually happening in the control. And you always feel the same, For example, this Airbus 380, you fly with the side stick called a joystick. You can actually fly it with fingers. That whole aircraft will take off with just about 1 or 2 taps. You just put very little bit of amount, the whole aircraft takes off. So that's artificial. Just like when we are driving our car, right? Last time the steering is very heavy, right? Now they have hydraulic system introduced, so it becomes very light. So similar to that, that's the artificial thing. And then of course the higher technology, now they are looking at fly by light. Instead of transmitting through the electrical signal, now it's going through the fiber, fly by light. Some high tech fighter aircraft, I think they are into this research. Yeah, similar to that, artificial feel. Yeah.
Okay, we have a question from Dr. Wan Mazrina. Good morning, Captain. Thank you for sharing very informative and interesting facts indeed. How can we approach aviation industry to allow us to do research on human factors, for example, risk assessment and aircraft maintenance? Whom to approach?
Okay, this one, okay, who to approach? You can approach SIG lah. Dr. Helmi kan ada, he can coordinate for us. Which specific area that you want to do? Then we can approach. I mean, from the maintenance part, maintenance also again is very big. If you want to see what maintenance you want to see the day-to-day line maintenance which is happening at the aircraft at the gate, or you want to go to the aircraft hangar. It's again another big area. So of course you can come and contact us. We can talk about it, and then I will introduce people for you to do it. I introduce to the people. Either you can go Asia, Malindo ke, MAS ke, or you can go on a helicopter company ke, So there are many opportunities for this. Just talk to us. Later on you get in contact with us.
Okay. Right, just a question from me, because I'm doing a lot of motorcycle simulating using simulators. How immersive is a pilot, okay, practicing in a cockpit of a simulator compared to the real world of how
Okay.
real is it? How does it feel basically?
Okay. It is almost, I can say, 80%. Okay, 80%. This is my number I'm giving. Because because it's very high fidelity simulators. High fidelity simulators, and in fact, some of the simulators now, level D simulators. There's a different type of levels certification. So if you look at level D simulators, we can do certain training even in the simulator. Now, because this COVID, we are not flying that much. In fact, some of our check flights are all done in the simulator, and that simulators are certified as an aircraft also. You know, the flight simulators is very advanced. You know, we can simulate a lot of things, turbulence. We can simulate different weather. We can simulate all kind of failures in the simulator. You know, you have engine fire, and we need to go to the simulator every 6 months. You know, this is every pilot. We need to do a thing called base check. So we need to go to the simulator, and we are given all kind of problems, you know, during takeoff, engine failure. Then we are flying, we have engine fire, and then we need to land with one engine, you know, another engine have failed. So simulators are highly used, and it's a really high fidelity. Yeah. And then even their visual system is also very highly accurate. It's called high fidelity flight simulators, and of course there's no end of it. There's a lot of research being done. For example, I went to this university in Delft, you know, Delft in Holland. They are doing this simulator, and of course that simulator they can change into a car or different, you know, motion cueing. One of the research now is it's called motion cueing, you know, like the depth perception, how you put it in the simulator. You know, we're coming into land, right? So the depth, how do you feel the depth in the simulator? You know, so another area, you know, in Malaysia, there's nobody doing into flight simulator research. In fact, I do not know anyone.
Because I've seen a flight simulator for fighter pilots, right? So they have this very immersive surrounding, and in commercial airliners you cannot do the upside down maneuver, right? But in jet fighters, could that be simulated, including the G-force? Could that be simulated?
Yeah, because this is called, you know, there's two types of simulators actually. You know, one is the fixed base. That means the when you sit there, the thing doesn't move. Only the visual moves. So to simulate a feeling, okay, simulate a feeling that you're moving. And then another one is called a 6 degree of freedom simulator. Okay, so actually the simulators can go up and down and give you the feeling. Okay, can give you the feeling of you're actually moving, your body parts are moving, you know, your senses are can feel it. But that's a bit expensive to operate because, you know, you need hydraulic systems and all that. So in fact, we can go and visit, you know, to MAS. And then in fact, I've been with J. Amma. I went to the MAS simulator, and we flew it. So that's another thing that we should visit, you know, in Complex A near Subang, you know, there's the simulator center there.
Okay, right. We do have a question in the chat room from Wan Norizan again. How cabin crew and pilot overcome or tackle the stress and workload during the flights?
Okay, this is very subjective again, you know. Stress, what type of stress, you know, is either it's a personal stress or it's a work stress, right? You know, sometimes you bring the stress from home, you know, you had a quarrel with your husband or wife, and then whoever it is, you can also bring that stress. And then sometimes you add on with the passengers stress, you know, you ask them to put on seat, they don't want to put on, ask them to switch off the telephone, they do not want to switch on the telephone, you know. Workload. We have a thing called crew resource management. There's a course that we do that proposes some solutions, you know, stress and how do you work, workload and all that, you know. But again, all these are just theoretical classes, you know. But that's the reason the selection of cabin crew and the selection of pilots are very important. See, these are the things that looked in during the selection, you know. If you cannot handle this, you know, there's a way, you know, there's a psychological test and all this being done, and we can, not 100%, I think up to certain level we can identify this, right? And again, this is the reason that we need to be professional. That's why we are called professional pilots and cabin crews, you know, because if you're professional, if you think that you are under stress, you need to declare that you're under stress, you know. And very easy for us to get MC. You just go and see the doctor, you say, I'm a pilot, I'm stressful. Immediately, we give you MC. You know, no question, because he don't want you to go and fly and do something nonsense, right? So how do we overcome? You know, there are coping methodologies that we need to practice ourselves. Yeah.
Okay, right.
Yeah.
So we do have another question from Mark. Good morning, Captain. What aircraft did you already handle in airline industry? Okay, and did you experience some errors of fatigue while on flight?
Okay, I've flown the small aircrafts up to even 747, 777, and now on the 787. That's very advanced modern aircrafts now. What are the errors? Oh yes, I make errors. That's why we have two pilots in the cockpit. Two pilots in the cockpit. If you make error, the other guy catch it. Okay. Fatigue, yes. Flying through the nights and all that. We have thing called in-flight rest. In-flight rest. We are allowed to rest in flight. A short rest. About 20 minutes we can take a short nap. Okay. And other than that, also have certain flights. We have 3 or 4 pilots. So 2 guys work, 2 guys go and have a sleep. And if you feel tired, you let know the other person that you are tired, and then you can take a short nap. And of course, you also check on him, whether he is tired or not. The moment we realize that, we go and freshen up, try to do something that keep us active in the cockpit. Have a coffee, talk about something which is interesting. So we need to handle this. This is very important for us. Yeah, because coming into land, if you're sleepy, there are accidents happens. One of the reasons accidents happens is because they are very, very tired. So when you're tired, you cannot make good decision.
So that tiredness or that fatigue, because you said that due to the technological advancements, right? You sometimes only touch the controls for 5 minutes to take off and also landing. So along the prolonged flights,
yeah, so that's why
you're sitting,
tired,
right?
If you're tired, yeah, most of the time you're sitting. So that's why sometimes we need to stand up, go for a walk, walk behind and come back, and also we can do some simple exercises in the cockpit. Probably also, our group can come up with what are the exercises the pilots can do, or the cabin crew can do. Some suggestion, we can.
So currently there's no exercise, is it?
We all come up with our own type of exercise,
Okay.
Own type of exercise. There's nothing that proposed by anybody. Yeah. And one of the reasons we get tired is also
very good
yeah,
research on that.
Yeah,
there's a question from Mr. Moafirdos. Good morning, Captain. Interesting presentation. Okay, my questions, there's 2 questions here. What are types of distraction exist among pilots while they are control or maneuvering the aircraft? Are there any aircraft crash due to distractions? And the second one is, in terms of flight simulator, is there any international standard that need to be complied by the aircraft company or pilot while they are develop or operate or utilize the simulator?
Okay. The first question, the distractions. There are many type of distractions. Even from the ground. Sometimes you're preparing something, then suddenly the refueler comes to you and give you how much fuel is there. Or suddenly sometimes there's a passenger problem. You're talking to air traffic controller, because we are using these radios, right? The radio sometimes is not clear. We can't hear it properly. So that's also can become a distraction. Some sound, coming in. Actually, many, some of the things I said, are there any aircraft crash due to distractions? Yes, distractions, sometimes some, I can't remember any particular cases. Okay, one of the cases, distractions. Okay, this accident happened in America, in Everglades. So they were coming in to land, and then they had this problem with the landing gear. The landing gear does not want to come down. It's stuck up there. Doesn't want to come down. So they start to find a solution for it. The light bulb, which shows whether the gear is down or not. It's not. There's no light. So they were distracted by this light, and by the time they're trying to solve this problem, the aircraft was going down and down and down, and eventually crashes because they were distracted by something. The light, the gear is not coming down. Instead of somebody, because that's why we have 2 pilots. Somebody's supposed to be looking at the actual aircraft flying, but both of them were concentrating on this distracted light. The aircraft eventually crashed. This very famous accident. Yeah, if you're in our group, then I can share this case. You know, you can go and watch it. Yeah. Okay, number 2, is there a flight simulator international standard? Yes, it is. We must comply with this standard before the airline can buy the simulator, and then this simulator must be certified by our civil aviation organizations. Then only you can use the simulator. Okay, otherwise, if you use any type of simulator, you are basically not certified. Whatever training that you do is not counted. You know, so you want to do a simulator which is certified. Yeah, there is. Okay.
Okay, we have a question from Mr. Husamuddin. So this on food intake. Any supplements you take to maintain mental alertness? Because we do have professional athletes, they have these supplements. So how about professional pilots?
Yeah. This I think again personal thing. You know, I don't take anything. Most if I take also maybe before the flight, if night flight, I take a little bit of glucose, maybe just to alert myself. But some takes multivitamin. This is very personal. You know, there's no anything which is recommended supplements for us, as far as I know. There's no any particular supplemented. Maybe you can do a research on that. You know, you look at all the pilots, and then you give you whatever supplements, and then you see whether they are alert or not. You know, so there's no particular recommended supplements. Yeah.
Okay, Captain, just one question from me. Along your experience in flying these airliners, what is the most maybe scariest incidents that you have encountered? Okay, from the passenger side, maybe medical cause or anything. Any experience on that?
Okay, generally passengers is this another type of research, which is also can be done, for passengers' psychological effect, when they're sitting behind, because you can't see much, you only can see outside from the small window what's happening outside, right? So when there is a turbulence, the passengers generally get very scared, very scared. So that's why sometimes we, as a pilot, we need to come out in the PA and then we say, gentlemen, actually the situation is under control. The turbulence that we are experiencing now is actually very safe. It's not nothing. We're just going through a small cloud, and then it will settle down very, very soon. Everything. So they want to see this assurance from the commander coming on the PA or the cabin crew, right? But the passengers will really, really get scared when they see even the cabin crew is crying, sometimes cabin crew also very scared, because they are the role model there, see the cabin crew is scared, even then they are even scared. So that's why, the cabin crew must be also have this leadership role to play, especially these young girls, all the new airlines, they recruit very, very young girls. So, so one is obviously a turbulence. People get very scared. Another one is technical things. If some sound that you hear, boom, in the cockpit, in the cabin, passengers very, very, very. And I get this information from the cabin crew. They'll come and tell us, these passengers are very scared and all that. So then we can go on the PA and give assurance to them. Give assurance, nothing to worry too much. Everything is okay, safe, because we can see more things from outside. Right, our cockpit windows are bigger, and we have all the technical information. All right. So personally, where I'm scared, not really. We are trained to handle most of the things. So if I become scared, then it's bad shit. So we should not become scared. But we need to take appropriate action. Yeah. Okay, but most of the training we have done all kind of training. Yeah.
All right. This include the cabin crews, is it? Because they are very calm normally when it comes to turbulence.
Yeah, they need to be calm, Yeah, they need to be calm, and because they have seen enough, basically when you get turbulence, just put on the seatbelt, follow the seatbelt sign. Don't try to be champion.
Okay, another question from
Mr. Raimi again. Sit there and relax, Yeah. Okay. Mumble the announcement to passengers.
Yes. Why is that?
Okay, there's depends how you look at it. Sometimes it's because the PA system is not good. The way the PA comes in, it sounds like it's mumbling. All right. But again, some of the we go through in the airline that I'm working with, we go through a training for how to make announcement, how to make a good announcement. Okay. And of course, if it's an old aircraft, you make announcement, doesn't matter what type good announcement that you make, the PA system doesn't sound good. Okay. My announcement is normally very short. I don't want to give too much of information. In fact, now passengers not so interested to listen what you're talking. In fact, the modern aircraft, they're probably watching a movie or what. When you make announcement, the movie stops, and then they get pissed off with you. So, and most of the information they can get from the screen. In fact, so I don't like to talk a lot. Why they mumble? This is personal. Sometimes some trying to use all kind of slang, trying to talk like masala and all this. So just be normal and just keep it to the simple English and just give the main information you want to give. Basically the passengers are mostly interested in what time you want to land. That's about it. What temperature is outside. We're flying. Some of them not interested. So just minimum information, and in fact, if they want, they can ask the crew. Yeah. Why they mumbling? I think it's very personal. You actually next time if you fly in an aircraft which is the pilot mumbling, tell the cabin crew about this. You just give a feedback to the pilot.
Okay, right. Yeah. Okay, maybe Mr. Remy has come to this experience, I think.
Yeah.
Okay, right. Maybe any questions from the floor? Anyone would like to say any words? You can unmute yourself and speak to Captain Kanan. Anything? Maybe
how many people
we do have 60 on board today.
Oh,
okay, Captain. Normally when we doing the taxiing of the aircraft, right, on the runway, so cabin crews will demonstrate all these safety issues, what to do, right? So in an actual scenario, how calm are the passengers to follow all these procedures? How calm are they? They need to be on the floor if there's smoke. How calm?
The actual, or if there's
in actual situation, maybe emergency landing,
actual emergency,
anything. Yeah.
Okay.
Yeah.
Okay, if you look at when actually something happens, passengers become very difficult to control. Very difficult to control because everything goes haywire. Because everybody want to save their own life. All want to run out. All want to run out. In fact, you get some of the videos, they will climb on each other. Climb on the seats and then try to go out. Okay, so actually the research shows
they'll
that
take all the personal things, right?
During this, during the certification for this emergency evacuation, we must evacuate within 90 seconds. That is the standard. And with the half number of doors, let's say this aircraft got 8 doors, 4 of the doors will be locked, and then we must exit using only 4 doors within 90 seconds. So that is the requirement for certification. So when they design this aircraft, there will be a simulation being done, and everybody need to come out within 90 seconds. Requirement for number of doors, right? Of course, this certification is people know what's going to happen. All right, so everybody is ready. They will take all the people with good physical only. But in an actual flight, you have very old people, we have very young kids, we have very muscle men, so all type of people. And some people have had some alcohol. Some people are sleepy, so there's a variation, big variation. Okay, and all these people need to come out. So that's why when you check in for flight, the check-in counter, actually they will look at people, whether you are obese, whether you are old, and the seats are given according to this. They don't want to put a very fat guy in a seat which is outside, to exit seat. They don't want to give. They will not give normally, because this guy can stop from the other people to come out from the seat. Let's say there's somebody sitting near the window. He cannot come out because this guy is is obstructing the other person. All right. So the seat allocation is also looked at during the, when you check in. Old people, they normally give you a window seat and this like that. So this, you need experienced people which have human knowledge, human factors knowledge, even at the check-in counter, whether this lady is pregnant or not. So they will give an assessment. Actually, those experienced check-in counter staff, they will assess you actually, where to put you, which seat to put you.
Okay.
Right. Emergency evacuation is a complex stuff. So 90 seconds is one of the rule, and half of the seats. For example, now with the low cost airlines flying, you imagine, when you sit there, you observe the people. A lot of them don't have flying experience. You can see, 30, 40, sometimes 50% never flown in an aircraft. They can't even put the seatbelt on, properly. They don't know how to put the seatbelt on. That's one. To release the seatbelt in an emergency, let's say the cabin is full of smoke now, full of smoke. People do not know how to release the seatbelt. That's a simple thing to do. We think it's simple thing to do, but they do not know. Let's say the aircraft is upside down. How to release the seatbelt? People have struggled to do this. There's one crash happened in America, Sioux City. And most of the people doesn't know how to release the seatbelt. So that's why this cabin crew must give very firm instruction. So it's very important to watch the safety videos, the safety demonstration. A lot of people don't want to watch, because different aircraft can have different locations of your, when you want to, let's say the aircraft ditch on the water, right? So you need this safety jacket, right? So people do not know where it is located, how to take it out, how to put it on, and most people will inflate it inside the aircraft, I think. So once you inflate, everybody become fat now. Right? So how to exit this within the small door? Okay. Then when you want to jump out, how you want to sit, how you want to go. And then if you see fire outside, how you want to exit. So this emergency is another issue. So it's good that if we can organize a trip to the airline and to see, because we need to do this every year, how airline crew practice this, because this we need to be certified every year.
Okay.
Yeah.
Okay, right. Okay, we do have maybe a last one from Rosini.
Okay.
Okay, great and tremendous knowledge to share, Captain. I'm interested in ATC personnel. Is it any specific selection criteria during hiring of those personnel, ATC? I mean, I know the ATC personnel need to monitor how many flights at one shift time.
Okay. The ATC selection, this is one area that many people do not know. There's a job called air traffic controller. Okay. It's recruited under the JPA, Jabatan Perkhidmatan Awam. And you can see the advertisement comes out in the newspaper, I think, okay, or JPA website. So the selection is, of course, you apply and then you go for an interview. There's a minimum requirement. You must have now, I think, at least a diploma. Okay, at least a diploma. In fact, this is one job. I think this is one of the highest paid civil servant job. And you have a lot of holidays. You have a lot of break days, in between. So this you can, people do not know about this job. So minimum degree or diploma in any area. In fact, in any area, you just pass the interview, and then you will be given a training. Of course, before the interview, they also have some tests, IQ tests and all that you need to pass. And then there's a department under the civil aviation. It's called MAWA, Malaysian Aviation Academy, which is near the the Formula One race track. There is somewhere there, the MAWA. So you need to go through a training. I do not know exactly, about a year or so. Then they will send you to the air traffic control centers. Then you do a lot of on the job training. Okay. Very interesting to visit these control centers. Okay. Very interesting. And may I know, ATC personnel need monitor how many flights at one shift? Okay. There's no exact number they need to monitor, because these aircrafts, it comes into your monitor, then it goes out from the monitor. It doesn't stay there, because you need to pass from one controller to another controller. So it goes on from one country to another country. So let's say, for example, it's coming from north, our air traffic is connected to Thailand. It also connected to Indonesia, connected to Vietnam, and connected to Singapore. So we can pass the aircraft. Some aircraft doesn't land in Malaysia, it just overflies. It just pass through our airspace. Some come and land, some take off and goes. So we have one controller, they have separated this controller, ground controller, tower controller, area controller, departure controller, approach controller, you know. So if you see in Malaysia, in West Malaysia, Peninsular Malaysia, they have divided into, I think, about 7 sectors. That's beside we have Penang Tower, we have Kuantan Tower, we have Johor Tower. That's another group. So there's no exact number to give, but there, I think, I don't know, maybe sometimes they can handle up to 15 aircraft, you know. Some guys just overflying, you know, you just call them and then talk to them, and then you look at another one. So that's why air traffic controllers need to have this capability of having a abstract. They can see, because the aircraft displayed on the screen is 1D, right? One dimensional. But they must be able to imagine in their head in 3-dimensional. This aircraft is flying at this speed, this aircraft is at this height, and this aircraft is going at this direction. So they must be able to have this 3D perception in their mind. What they see is 1D, but they must be able to get it in 3-dimensional. So that's another skill that air traffic controller need to have. So this all this you get through the training. You know, some people may fail this training. There's another simulator in Mava in the training center in near that KLIA there. It's also interesting. It's a tower simulator. You know, once you go into the simulator, it's like you are standing in the control tower. Okay, you can see all this aircraft movement going, you know, and then they can simulate this aircraft got fire. So this is one of the training they need to do. That's interesting, you know. Maybe we can organize a trip there also. Tower simulator. Yeah. So the answer is how many flights at one shift? Yeah. So and they shift, the air traffic controllers, I think they only work about 3 to 4 hours one shift, and then they go for a rest, 30 or 40 minutes, and then they come back, because they cannot keep on looking at the screen for too long. And one person at the screen, he will have an assistant sitting beside. So they will help with the planning. One guy will be talking to the aircraft. So there's a lot of teamwork. There's a lot of coordination which is happening. Yeah.
Okay, right. So I think that will end our Q&A sessions. All right. So it's a very interesting topic today. I think we do still have other questions. So, but the time is already.
My screen. Is my screen still on?
Yes. You have your contact there.
Okay. That's my contact there. You all can contact me there or message me if I can answer. So if you cannot get it, please go through the SIG. You know. So this is our human factors. That's what we want to see. So we want to promote this SIG also now.
Okay, so to all the participants that have not joined yet HFEM, okay, you could go to the HFEM website and look into the membership, right, and help to follow and also be one of the members in this HFEM society. Okay, the only ergonomic society here in Malaysia under IEA, so that we could contribute along to human factors and ergonomics in Malaysia, right? So there's some there's some announcement from the Secretariat. Okay, please sign your attendance from the link in the chat room, and also the evaluation form for today's webinar. Okay, I would like to invite everyone to open their camera for us to take a group photo. Okay. So while waiting for others to open their camera, Captain, can you stop share so that we can see everyone?
Okay, stop share now.
Yes. And then while waiting for the others, maybe everyone to sign in the attendance and also the evaluation form for the Secretariat do further analysis on today's webinar session. All right, so we do have 60 just now, and we do have 55, so it's very good. Right, I do believe.
I think there are also people from. Dr. Helmi, I think
yes.
I can also see some people from engineering, you know, very experienced engineers and all that. So
yes,
those want to do engineering type of research, I think these people can help.
Yes, sure. Okay. I think most of us are still.
The next time we can probably invite them. Invite them under the aviation to give them, you know, specific on engineering and then specific on air traffic control and all that. You know, we can organize that.
And also
they will
maybe
have more knowledge than me.
We could organize under our SIG for the trips, Captain. Maybe you could open
no, only if they join our only if they join our society.
Society, yes. So please look into our website again, HFEM. So there's lots of information there. There's also other SIGs there, and also basically under HFEM we do have many backgrounds of people in there with different areas and different expertise, especially relating to human factors and ergonomics. But if you are not in this area basically, but you still can join us, okay, and you can still contribute on how could you contribute to the nation. Okay, so there's 3 screens here, right? So I would like to capture the first screen. Okay, so everyone ready? Okay, maybe you would like to open your mask, right? Okay, right. Okay, so please smile. Okay, 1, 2, and 3. Okay, wait. Okay, wait. Just to save this. Okay, I'll be going to the next screen. Okay, those in the next screen, smile. Okay, and then the third screen, we do have the third screen. Okay, smile. Okay, so I think we've come to the end of this session. Anything else from you, Captain?
Actually, nothing much. First of all, thanks for the invitation and the time. And then,
you want to use for what?
You use for what? I tengok dia punya electrical wiring diagram.
Okay, hopefully more people will join this you know, HFEM SIG, which is, I think a lot of people doesn't know this thing exists, you know, in Malaysia. So the, you know, we can invite, you know, in fact in aviation we can invite the air traffic controllers or the engineers and ground staff and all that to also join. There's a lot of research opportunity. That's why I'm trying to say through this mainly this webinar. All right.
Okay, thank you again thank you again to our Captain Kanan Parumal for all the talks and also all the participants. I do see a few of my students here in our webinar today, right? So those are the students. You could still join us under HFEM under the student chapter, right? So be a part of the society, right? So that you could expand your knowledge on ergonomics and also spread the awareness among other of your friends. So I think that's all for today. Thank you very much again to Captain Kanan Parumal for the talk, and also thank you again for all the participants, and also to Ms. Sabrina, the host for today. So hopefully we'll see you again in the next coming webinar under the Transportation SIG. And I wish everyone a very pleasant day ahead. All right. So thank you very much. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day. Thank you very much.
Yeah, thank you.
Captain Kanan, there's some of the participants are waiting for the slides. Could you share the slides? Maybe Sabrina can help to disseminate the slides.
Okay. I will pass to Sabrina later on. I will email to her because
Yes,
maybe some of the slides I want to remove or what.
Yeah. Maybe some that is a PNC maybe.
Yeah.
Right.
Yeah. Okay.
Right. So I think that's all. Thank you very much again, Captain.
Okay, Doctor. Thanks a lot.
Right. Thank you. See you again. See you, everyone.
Okay. Bye.
Bye.
Thank you, Captain. Congrats, Amy.
Who is this?
Remy, is it? Yes.
Remy.
Mr. Remy.
Yeah.
Okay.
Tanya.
Cannot see your face.
I would like to ask about the MH actually.
Sekarang boleh lah kalau tak record.
It's still recording.
Oh, we can talk.
Sabrina, it's still recording?
Yeah, I can stop recording now.
Yes. I think we can stop.
We can talk privately also lah.